Today's presentation is using the AccuSizer single particle optical sizing system for contamination applications. Now, simple light obscuration or light extinction sensors, same thing, just a different phrase, have been around for quite a while. Basically, a particle passes through a light source and the light interacts with the particle. It casts a shadow, but there are other interactions as well. That generates a pulse. The pulse is fed to a pulse height analyzer, and through the use of a calibration curve, we then generate the particle size distribution one at a time, and we also get the concentration in particles per milliliter. A major improvement patented by particle sizing systems is the addition of a second sensor, the scattering detector. So in the sensor used in the AccuSizer systems, we have two detectors, the extinction detector and the scattering detector. Essentially, the extinction detector is used to get information for the larger size particles, and then as we get down near a micron and below, we actually get more information from the scattering detector. We take these two signals, we compress them, combine them, generate a composite pulse, which is then fed into the pulse height analyzer. And now, using an extended calibration curve, we again build up the result one at a time and also generate the particle concentration information as we generate the result. In this short video, we'll actually see the particles interacting in the two detectors here, the extinction and the scattering detector. So the particles pass through a constricted flow region. That is where we generate these pulses, and from those pulses we generate the particle size distribution. The LE400 sensor is the most typical sensor used when we're using the AccuSizer for contamination applications. This is where we have the combined light extinction and light scattering response. This sensor has a dynamic range of 0.5 to 400 microns, and there is an upper concentration limit of 9,000 particles per ml. There is an upper concentration limit because we can only have one particle at a time passing through the sensor zone in order to generate the most accurate results. In the lower left, you see one particle at a time passing through the sensing zone, but here in the lower right, where you see two particles at the same time in the sensing zone, in this situation, we would actually combine these two particles into one larger particle, creating a coincidence error, and that's what we need to avoid. So we always need to work within this controlled concentration limit for the most accurate results. Because we have to work within this concentration range, we need to make sure that we pass the sample through the sensor at the proper concentration. Now, for samples where there's very low concentration, we can use systems where there's no dilution required, and that is the AccuSizer SIS system here. And also we can use the A2000 either without dilution or with dilution. If we want to work at higher concentrations, we either use the A2000 and use the automatic dilution feature, or we do have other systems, this is the AccuSizer AD and the AccuSizer APS, where we can actually dilute down with either single or two-stage auto dilution. And this way we can work at higher concentration samples, but still generate the result both in terms of particle size, concentration, and the size distribution for the entire range of the particles in the sample. These are all laboratory units. We also have online systems where it's important to do process monitoring. And here we see a point of use or a tower system where we could multiplex multiple lines through the system. So we can do these measurements both in laboratory and online. The most common system for contamination application is the A2000. This uses the LE400 sensor, which has a dynamic range of 0.5 to 400. And as you look at the flow diagram here, there's two ways this could be used. We could use a single pump and draw the sample up out of the sample container and through the sensor and then measure without any dilution. Or if we add a second pump, we could have filtered diluent here. And what we would do now is actually bring in both the sample in the diluent. It goes through a static mixer, and this way, let's say that we have a hydraulic oil where it's fairly high concentration. This way we can automatically dilute it, and there's no reason to need to pre-dilute the sample before the measurement. So this is a very flexible system that can be used in a range of applications, including water analysis, hydraulic oils, general contamination monitoring, or parts washing. This is a fairly quick measurement time for most samples, around a minute. It can either work with aqueous or organic samples, certainly with hydraulic oils, up to a viscosity of about 100 centipoise. A very common application for contamination monitoring is in oils, either hydraulic fluid or it could be lube oils. There are various international standards where we can rate the contamination level in the oil by measuring at multiple particle sizes. The most common standard used is ISO 4406. And with ISO 4406, we make note of the particle concentration at 3 size ranges, 4, 6, and 14 microns. So we take the results at those 3 different size ranges. We look at the concentration, then we refer to the table here. So for instance, if we have 46 particles per ml at 4 microns, we come over here and we see that that is scale number 13. And what we will do is report the 3 scale numbers at 4, 6, and 14 microns. And this is a way to completely describe the concentration level and size of the particles in hydraulic oils. A very common application of the use of the A2000. Another common use of the A2000 is parts cleaning, and this could be in the aerospace industry or the microelectronics industry. And what we do here is we have parts where we need them to be as clean as possible. And what we do is we pass these parts through some kind of cleaning process. It could just be hosing them down. It could be placing them in a vat where there's an ultrasonic cleaner. And what we do is we clean the parts, and then we take the liquid after it has passed over the parts and run that through the particle sensor. We measure the size and concentration, and we may actually just clean the parts until we reach a desired particle count of the liquid that is used to clean the products. This can be done either as a laboratory measurement, or as you see here, this was a custom parts cleaning system that we created for a customer a few years ago. Where in the front, this is actually where we're doing the flushing of the parts here. And in the back, we have the sensor, the control electronics, and also a filtration system, so we can continually reuse the wash fluid. And in the right here, you see the particle concentration upstream and downstream of a parts cleaning process. Another common application where we use the AccuSizer for contamination is looking for particle count in parenteral drugs. Parenteral drugs are drugs that are introduced into the venous system of the patient. So these are injected into you, and we want to make sure that there are very few contamination particles in these drugs. Here we use the AccuSizer SIS system, which is a syringe sampler, and we can either configure it with a single sensor or with 2 sensors. In the single sensor configuration, we use the LE400 sensor, which measures from 0.5 to 400 microns. Or if we use 2 sensors, then we can measure a very wide dynamic range of down to 0.15, which is 150 nanometers, up to 150 microns. This system could be used for any sample where we don't need to dilute the sample, but there are some specific requirements when measuring according to these USP tests in the pharmaceutical industry. When we're measuring according to these USP tests, then we need to follow a prescribed procedure. In the prescribed procedure, we measure at certain size ranges, and we can set that up in the software. We can either use the single or the 2 sensors. We can measure a very small sample volume down to 150 microliters when working with very valuable fluids. And by the way, you can recover that sample so that you could use the same sample to conduct other tests. Here we can measure down to 150 nanometers, and when we're measuring down to small sizes, since there's always more particles as you get to smaller sizes, with the FX nanosensor we can actually work at much higher concentrations up to the scale of 10 to the 6 particles per ml. Now the actual requirements in USP 788 and 787 are only to measure at 10 and 25 microns. But actually, if we want to understand what's going on with something like a protein aggregation process, we can actually measure up to 512 size channels and see the complete particle size distribution. And that's one of the bonuses of actually using the AccuSizer for contamination applications. In addition to using it as a contamination monitor, you're actually also using it as a high-resolution, high-accurate particle size analyzer and can see the complete distribution of the particles within the sample. When performing a basic USP 788 test, there is a prescribed procedure where it tells you, depending on the volume of the drug, is it less than or more than 100 mLs. We do 4 measurements, discard the first, average the last 3, and then we record the particle concentration at 2 sizes, 10 and 25 microns. And there's a pass-fail criteria, which changes depending on, is it above or below 100 milliliters? Is it a small or large parenteral drug? This test is automated in the software. Here you see the screenshots where we set up the measurement. On the left we have what we call our research software, and on the right our 21 CFR Part 11 compliance software. Either way, we tell the system, is it a small or large volume parenteral drug? We choose the size ranges we're going to measure at, the size of the containers, did we pool containers, the various other information. We enter these parameters and then we just hit start or go, and the measurement is completely automated. At the completion of the measurement, the results are displayed showing the pass-fail criteria depending on the kind of sample we're measuring. So the pass-fail criteria is based at 10 and 25 microns, and we see here that this sample passed at both size ranges, and over here we also see that this sample passed. Now there could just be a display showing the user-defined channels, maybe just at 2 or 3 size ranges, or we could display the complete size distribution using all 512 size channels available in the AccuSizer system. The last application I'm going to talk about today is filter testing. So downstream of filters, filters by definition are going to remove particles, and we want to know how were the particles removed, at what size range, what was the efficiency. So here we're looking at the particle size and count, either downstream of a filter or upstream and downstream of a filter. Here you see a picture of a filter test stand where we could have sensors both upstream and downstream of the filter. And if we look at this ratio of upstream to downstream particle count at given size ranges, that is called the beta ratio. And that helps us understand how efficient was this filter. And we can look at counts upstream and downstream of the filter. In the lower left, we see particle counts upstream and downstream of a filter in a CMP slurry. This is in the microelectronics industry, where the particle count and size, especially above 1 micron, is critical because that could cause a decrease in the yield of the integrated circuits. And in this case, where this is so critical, people actually use a point of use AccuSizer, which you see here, downstream of the final filter to make sure that there are no particles larger than what are expected hitting the integrated circuit surface. In the right here, we see another typical application where we're interested in the filter efficiency, and this is for inkjet inks. Here we're looking at results of an inkjet ink, which is unfiltered, filtered using a 2 micron filter, and filtered using a 5 micron filter. And here we see the particle concentration greater than 1 micron of the unfiltered sample. And we see at 5 microns we have around 68,000 particles per mil, greater than a micron. And when we then use a filter with a rating of 2 microns, we reduce that down to 21,000 particles per mil. So here we see using the AccuSizer as a way to decide what is the best filter to use for the given requirement for this application. So the AccuSizer can be used for contamination monitoring, and it's actually the highest performance contamination monitor on the market. Why is that? Because of the wide dynamic range of the sensor. Also because of the up to 512 size channels, you actually are bringing not only contamination monitor, but a particle size analyzer into your laboratory that perhaps you could use for other applications. We can do these measurements either in the laboratory or online. And for laboratories that have a very high sample load, we can also hook up auto samplers in conjunction with the instrument so that you can set up a rack of many samples and automatically get through these measurements. Now we do have documents on our website if you do visit the Documentation Download Center, where you can download application notes specific to filter testing, specific to USP 78 testing, specific to various applications, as well as information on each instrument. So we do recommend you visit the Documentation Download Center to get additional information on any of these systems. So I want to thank everyone for attending today, and if you need more information, please visit our website.